This program covers 3 types of fan drives: direct drive, viscous fan drives, and on-off fan clutches. There are many manufacturers of fan drives, and most will be discussed in detail. Addressing some facts about low-temperature aftercooled engines is an important introduction to your options. Low-temperature aftercooling demands that fans move air through smaller, more restrictive radiators to achieve the proper heat rejection. This means that fans turn faster, requiring fan clutches and hubs with high torque capacity and longer bearing life. Although this may sound complicated, choosing the best fan drive for your particular operation is easy once you understand how each type works and what their applications are. Direct drive or fixed ratio fan drives are the most basic of the 3 types. These drives run 100% of the time regardless of the engine temperature or operating conditions. This draws up to 40 horsepower, is unnecessarily noisy, causes considerable abrasion on radiators, and reduces belt life. Because the direct drive hub is in constant operation, its contribution to fuel efficiency is the lowest of all your options. SAE DOT fuel economy study results consistently show an engine with this type of fan drive consumes significantly more fuel than one equipped with any other type of drive. Viscous fan drives are hub-mounted, modulating, fluid-coupled devices that are never fully engaged or disengaged. In fact, they can run from 650 to 1000 RPM in the off mode, about 45% of the engaged speed. Viscous drives contain a hydraulic turbine with silicone fluid, which operates the clutch through centrifugal force. The silicone fluid flow is controlled by a bimetallic strip that senses the temperature of the air flowing through the radiator rather than the engine temperature. If the bimetallic strip that controls the clutch fails, the entire unit must be replaced. As you might expect, overcooling is a problem with the viscous drive. In addition, it may require a special fan blade to avoid excessive slippage. Slippage will lead to undercooling, causing the silicone fluid in the drive to deteriorate. This may also cause the fan drive to release improperly, drawing more horsepower in the process. It's also important to understand that the viscous drive cannot be rebuilt in the field or overridden for air conditioning condenser cooling. These factors combine to make this drive only slightly more efficient than a direct drive hub. Eaton and Schwitzer are the most common viscous fan drives. Because silicone deteriorates over time and is adversely affected by changes in temperature, both the Eaton and Schwitzer clutches have special storage requirements and limited product shelf life. This fact makes malfunction inevitable, requiring replacement of the entire clutch. On-off clutches are either totally engaged or totally disengaged, saving up to 45 horsepower when in the disengaged mode. Each clutch is controlled by an external thermal switch, which engages the clutch only when the engine requires cooling. This amounts to about 5 to 10% of the engine's total runtime. An added benefit is that engine noise is greatly reduced to well below OSHA limits when the fan is not in use. Since the fan runs less often, it draws less dust through the radiator, reducing radiator abrasion. Because less runtime reduces drive load, belt life is increased. Since the clutch does not draw horsepower in the off mode, fuel savings are dramatic. Tests have shown on-off clutches reduce fuel consumption attributable to clutch operation to only about 112 gallons per 100,000 miles of operation. That's a savings of over 2,000 gallons when compared with direct drive systems. This makes it the most efficient of all clutches available by a wide margin. The primary types of on-off clutches are electric and pneumatic. Electric on-off clutches are available in 2 types. The first utilizes a technology more common in the automotive industry. Flexolite and electric fan engineering have brought the idea of using electric motors separate from all engine drive belts to turn cooling fans. Because the size of a single electric motor capable of turning a standard truck fan is prohibitive, 2 small fans are coupled and mounted directly to the engine radiator. This dual configuration may require shroud modifications. Unfortunately, these motors require 10-gauge wiring and a 9-amp draw per motor, causing a significant drain on a vehicle's electrical system. They often require the addition of a high-output alternator. All the remaining clutches to be discussed are belt-driven, but there are dramatic differences between them. Belt-drive fans are more efficient and cost-effective than electric fans, plus they take up less space. This fact makes electromagnetic fan clutches a superior choice to other electric fan options. Electromagnetic clutches, like this Horton EC450 Corsair, are engaged when electrical current flows through the coil wires of the enclosed electromagnet. Current flow is controlled by a thermal switch that monitors the engine coolant temperature. While this design functions particularly well in light and medium-duty truck applications, the majority of Class 8 engines require fans and engine RPMs that create torque loads beyond the optimum capacity of these clutches. Now we will examine pneumatic or air-operated on-off fan clutches. Kaiser and Bendix both make single-cone design on-off clutches. These are spring-engaged and air-released. This means both require air 95% of the time when the clutch is in the off mode. Spring engagement has one major drawback. As the friction material wears, there is less pressure on the spring, reducing compression and the clutch's ability to handle torque. Both units are more susceptible to air leaks than other pneumatic clutches because they require air 95% of the time. This greatly increases the potential for failure. The Bendix clutch requires greasing and is susceptible to over-lubrication and bearing failure. It also does not lend itself to field serviceability. While the Kaiser is field serviceable, it is a hub-mounted add-on, eventually requiring both hub and clutch maintenance, unlike other on-offs that are a single unit. Air-engaged, spring-disengaged on-off clutches are generally considered to be superior to all other types of fan drives for heavy-duty truck applications. One brand of this type clutch is produced by Schwitzer. The Schwitzer on-off fan clutch is quite complicated in its construction and may require special attention when being serviced or repaired. It also requires regular greasing of the hub bearing, adding the risk of over or under lubrication. The most recognized name in on-off fan drives is Horton. With over 1 million of these clutches produced, Horton's rugged, basic design has been proven to eliminate the problems associated with unnecessarily complicated devices. From the ground up, the Horton features heavy-duty components. For instance, compare the Horton and Bendix journal brackets. The Horton pneumatic clutch line consists of a single disc type such as this HTS model, and these add-on clutches, the HT550 and HT750, which require drive hub water pump mounting. The HTS is an air-engaged and spring-released clutch built as a single unit, replacing the fan hub and reducing maintenance. As an add-on hub-mounted clutch, the HT550, which is also air-engaged, spring-disengaged, can be used to retrofit Kaiser or viscous clutches. Air engagement allows a self-adjusting action causing constant, even pressure across the clutch plate. This increases the Horton's ability to handle high-torque fans and eliminates any changes in torque handling due to friction material wear. Air engagement also provides soft, smooth, and complete transitions into the on mode. This means the clutch only requires air when the clutch is on, about 5% of the engine running time. In case of emergency, the Horton clutch can be locked into the on position with come-home bolts. The Horton clutch uses external controls for sensing engine coolant temperature and includes a solenoid valve filter assembly for protection against contamination and to facilitate operation in normally closed or normally open valve applications. Horton clutches also allow override for air conditioning freon pressure control. Another advantage of the Horton air-engaged line is its ease of maintenance and field serviceability. Only a few simple maintenance procedures are required. These drives have sealed bearings and need no greasing. If service is required, a seal or bearing kit can easily be installed without special tools or complicated procedures. Today, Horton has a variety of clutches available to handle most Class 3 to 8 trucks, school buses, and other vehicles. This includes the EC450 Corsair electromagnetic clutch for light and medium-duty vehicles, and the full line of field-serviceable pneumatic clutches designed especially for low-temperature, after-cooled, high-torque engines on heavy-duty vehicles.